Hi everyone, I am presenting the paper Detecting Tear Gas Canisters with Limited Training Data. It's an application research paper that we've done with forensic architecture. The objective of the paper was to develop a detector that detects tear gas canisters in open source videos found online to assist human rights investigators to investigate violations of human rights. The idea is to flag videos that contain tear gas canisters so that investigators can review them and decide whether they can use these videos as evidence for the investigations. The objective is to assist investigators and reduce the time they spend trying to find evidence for their investigations. We could not find data online that contained tear gas canisters, so our first main contribution is a data set that contains such images of tear gas canisters, and these images resemble what we can find in those videos that human rights investigators often use for their investigations. We've also created synthetic images. The dataset contain also images of images that contain objects that resemble tear gas canisters but are not tear gas canisters. For example, cans, aluminum cans, bottles, or anything that have these shapes that resemble tear gas canisters. We've separated our data into training, validation, and testing sets. The training set is rather small, especially regarding the subset of images that are real-life images rather than the synthetic ones. So one of the challenges is to train a detector that works well despite the small number of images in the training sets. We've adopted a few approaches. One of them is a few-shot detection approach. We've also fine-tuned the state-of-the-art detectors, and we've tested our detectors on the test sets and the validation sets. We've used three functions to score our detectors. One is MAP, the famous one, and then also recall and reduction. Reduction is very similar. Recall is to measure how many false negatives we miss, how many false negatives we have. Reduction is the number of images that we remove or we filter out from the test set or the validation set and which do not contain an object detector. An F2 score is a combination of recall and reduction, with the emphasis is put on the recall because it is important that we do not miss a potential video that contain tear gas canisters, rather than flagging more images that could contain tear gas canisters. We found that the few-shot approach does very well, and especially if it's trained on a very small number of images. We're talking about 10 training images. The best detector that we found in terms of F2 score, in terms of combination of recall and reduction within the few-shot approach was when we used a very small number of real images and a very small number of synthetic images, and when we also used images that contain objects that resemble tear gas canisters. In terms of fine-tuning approaches, the faster RCNN did pretty well. It got one of the best F2 score, and the YOLO V5 did have similar performance. In terms of MAP, the faster RCNN also performed really well. With fine-tuning, we found that it was necessary to fine-tune on as many images as possible from our training sets, and that is using the entire train sets. We did not find that using images with similar, like objects with similar shapes as the tear gas canisters to necessarily help these fine-tuning approaches. And in general, fine-tuning a state-of-the-art object detector does slightly better than the few-shot detector. Though again, we proved that the few-shot detection does really well regardless, especially in real-life applications.